to look at the number of supra-threshold clusters, and you want to count the number of voxels in these clusters that are in the left hemisphere versus the right hemisphere, right?
Yeah, and when I do the voxel-wise analysis, that's easy to do, right? Because I can find the clusters, then export a mask, and then just, set everything to one and count it. But I was wondering if I could do it with the ROI analysis. Like just within my ROI area, so not necessarily the ROI analysis, but just within the areas that I'm looking for the ROIs, do that same thing.
So instead of counting the number of suprathreshold voxels within the left hemisphere and right hemisphere, just to count them within a pre-specified ROIs, that is the question?
Yes.
So, and then run an ROI analysis. Well, but you don't have the suprathreshold. Do you have suprathreshold results for every individual subject? So
that's what I'm not sure. So that's why I'm not sure if I should look through the ROI file or if I should really just create some sort of mask of the areas that I want to look at and look at in the whole volume, but like with that mask. Like I'm not sure which angle to go down.
Right. I mean, for the group level results, at least if you have the voxel level analysis and the suprathreshold clusters on those, you can also just read those clusters within those like masks of voxels, basically. Read them using ROI analysis to basically count the number of suprathreshold voxels within each ROI. But that would just give you a number for each ROI. Is that what you want, or do you need to do that in a subject-specific manner?
No, I think that would work.
Okay, so that would be just reading you can use rex and just the GUI or the command line. If you use the command line, the two parameters that you need to send is first the file that you are reading data from, and then second is the ROI defining file. So for the data that you are reading info from, you can use the one that is called, I think it's called results.mask. When you have voxel results in the GUI and you click the export mask, it creates a number of files. One is kind of like an ROIs file that has a different index for every ROI, and one is just a mask of ones and zeros.
Yeah, so and that's what I use for the whole brain. That's what I was doing.
Right, so that's exactly the same that you need to use for the ROI. And then instead of just counting manually, you can just enter an ROI file to extract those numbers from a specific set of sub-ROIs, and instead of computing the average, select the option that says compute count, basically. Select the number of, it's just summing the number of ones that you have within each ROI.
Okay, and I can do that through the Rex GUI?
Yeah, you can do it through the Rex GUI or through the command line. I think let me see. If you do it through the Rex GUI, you just have to click on the sources and select the mask file. Then click the ROIs and select the ROI defining file, whatever atlas you are thinking of. And then change the measure that you're going to have a measure that says average or something like that, which typically extracts the average number of the average values within the ROI. Just select the one, change that to count, something that is called count, which is basically going to count the number of values above 0 within each ROI.
Oh, okay. All right. I may have a couple questions, but that definitely makes sense. Thank you so much.
No problem.
Sorry, Jason.
No problem. No problem. Everybody all set?
Mm-hmm.
Yeah. All right. So as we go through this is, in terms of a presentation, it's pretty rough. So let's consider this more of a conversation. And I will say things, hopefully that will trigger thoughts in your mind about things that you need. You can ask me questions, and I will update this as will be necessary. So we'll go through some today. When we started talking about the ROI analysis, I realized that for most of our ROI analyses that we do, FreeSurfer is key to doing that. And really, the way we've been doing this, where we have an FL pipeline for functional analysis, we're a DTI pipeline that Matthias is working on. And so I think that just in terms of introducing it, so imagine we went back in time a year and a half, and I was introducing this point in your lives that was useful. We want to set it up like this. So we'll start with this. This is the structural data processing. Pipeline's not really the right word, but it's the aspect of that in the lab. So when we do, we process our T1 images, so those are the high resolution structural images. We are using FreeSurfer. So today I'm going to mainly focus on using FreeSurfer. And I'm going to speed through a few things that I don't think are a big deal for you right now. and then we'll get to some of the things that are more relevant for you, and then we can backfill. So anyone that's interested in doing in learning about the aspects of running FreeSurfer, other uses that you want to do, what I'm planning to have ultimately is someone that goes through each of those in some detail. We have some tutorials already created, and I can do that at a later date. FreeSurfer, it's a powerful tool, and you'll see that what it's used. Well, I'll go through some of the typical uses that we do. So one is image segmentation, and by that I mean taking this T1 image that we get from the scanner and doing some things like getting rid of the skull, finding that, getting rid of it, then trying to find where in this image is the white matter. And what you have over here, this is another step in the processing here where the white matter that's in the red and yellow here is segmented away from the T1 volume. Okay, and then once we do that here, we can use that segmented image to do a cortical surface reconstruction. So we can take this segmented white matter here and develop a fully connected white matter, white gray surface. So when I say white matter surface in this, when I'm talking about in the context of FreeSurfer, what I really mean is that the white gray interface. And then from that surface, and I'll go through this a bit in some more detail later, we take that surface and then we can, using information about what's the intensity of the voxel right here in cortex, how far am I going, in what direction, I can then march this surface out and create a peel surface. So when you're talking about FreeSurfer, they use the term peel surface, and you can think of that as the brain exterior. One little side note is that FreeSurfer actually underestimates that peel surface. So if you were to do a very careful manual segmentation, your surface would probably be a little bit more inclusive. And the developers claim this is a feature, and I'm not sure if that's true or not. But the idea is, for most of the purposes that you're using, so FreeSurfer 1, it's going to apply that fairly consistently. So if you're doing some sort of comparative study, that the distance from the white to the peel surface will be consistent from one scan to another. They also claim that for most of the analysis that we're doing, besides morphometry, so if you're doing, trying to localize, or if you're doing functional MRI analysis, or you're generating ROIs for some other type of, any sort of analysis, that really the actions in this more interior portion of the cortex doesn't really matter if you're getting all the way out. So when we may see an example today, but certainly as you go, if you were to go through the reconstructions, so you can look on one of your own data sets, this very same image loading up all these different files, you'll see that, well, kind of looks like we're missing some cortex here or there, and that's sort of normal. As you look through these, you'll see what fits. It's not a lot, but it's
Is that something we should be worried about?
no, I would not worry about it. Where it gets tricky is something like the CWS project, the Children Who Stutter, from Swan's project in Michigan, because when subjects move a lot or the scan quality is relatively poor, you see that becomes a bigger deal. So for in those sorts of acquisitions, the gray-white contrast isn't as good, and then the contrast between cortex and just CSF, other surrounding tissue, is also not as good. So often what will happen is you can get a pretty good gray-white surface. So this surface looks pretty good, but then you'll see that the cortex, the intensity values of the cortex is low, and so you'll see stuff locked off. And we've already seen, I think everyone now has seen the effects on EPI images like functional MRI data and DTI data where you'll get fall off in these basal temporal areas and if I went more anteriorly, frontal orbital areas. And you'll actually, so that will actually, you'll see some of that in the T1s, and then you'll see where it'll lop off. So for in that the Suen study, there are a lot of brains where a bunch of the anterior temporal lobe, so the temporal pole is missing or blocked. A lot of it is omitted. So
a couple of questions, if you don't mind. So all of this is based on the actual image, raw image. It's not using anything like population estimates of where the gray matter would be or something like that, right? This is all raw, right?
So FreeSurfer does do that. So when it goes from this segmentation of the white matter to the surface, it's using population information about where it should be. And to answer your question specifically, I don't know if it's also using it in this march out to get the peel surface. I believe that it is, but I'm not 100% sure. So I would say I'm 66% sure that they're also using some population information to derive this peel surface. But it's got, so we won't go into the review process today. But one thing you learn is that if you can edit these, you can edit this volume right here that's shown in red, the red overlay here, the white matter.mgz or wm.mgz volume. And you can edit this brain mass volume and you can affect the quality of the surface. You can fix errors in the surface that way, or you can cause errors in the surface that way. And what you find is you can if you make a correction on the white matter volume, that may or may not have the intended impact that you want on the surface. So it's not a one-to-one. You can draw in more white matter, and the impact of that it's a little bit difficult to predict. Whereas with the brain mask, if you lop off a voxel here, there's a box, let's say this whole strip wasn't good, and there was a voxel sitting here. If I lop and in the initial recon, peel surface went out and grabbed that skull voxel, you can erase that, and then you know exactly what's going to happen. The peel surface will not go there. It will not include that within it. So I think that the scan itself has plays a bigger impact in what ultimately we get in the peel surface here. And I think that's for better and worse. So it's good because you really get the individual anatomy. It's worse in that you can have these issues where if the scan quality is bad, it affects the peel surface.
Right, and there is no gain or advantage or disadvantage to using the normalized structural rather than using the raw structural in these cases, right? For feeding that to FreeSurfer.
Well,
there is a recommendation in that end.
Well, so it actually does a normalization process as part of the recon. So if you go, this T1 here is already, I believe, I'm not sure yet. I don't remember if this T1 is, so this may be tweaked a bit, I'm not sure. But certainly by the time you get to the brain mask image, it does things like, it does a first guess at where the white matter is. And it'll take that white matter and then try to make the white matter more uniformly white and the gray matter more uniformly gray, so they can increase the contrast between the gray and the white. And then if I were to show, there's another image called brain.mgz, where it does that even more so, such that you lose some of the detail here of the subcortical structures, ganglia and thalamus. So it's doing that. One of the things that we considered playing with, but we just from a time standpoint, we didn't. But I would love if somebody actually wanted to do this. I'd love to work with them. Is applying filters. So you can do trying to apply some filters at a time to data that's poor, to get rid of noise, or to try to do a different type of intensity normalization maybe more local, because that would make, I think that would make a big difference. So if you could apply some sort of filter and say localize it, this is going in a different direction than I was expecting. It would be good to have some examples here, but if you could apply some filter, say around the anterior temporal lobe, and just essentially brighten up the image, I think that would help with the segmentation of that area and the surface reconstructions.
That's very cool. But I was thinking of normalization in terms of like a MNI normalization. So basically warping the brain so that it looks a little bit more like an MNI space, something like that. Would that help or hurt the FreeSurfer procedure to be able to do the segmentation? And
I don't think it would help, simply because they recommend that you don't do that.
Okay.
Or that's not the idea that you leave the brain with unnormalized in its native space is the recommendation.
Okay.
They do a match to a template, so that they actually, in the processing, that sort of goes on behind the scenes, where they do this, they call it a Talairac normalization, to align each brain with this population template that they have. And so that's kind of happening behind the scenes. One interesting thing, Alfonso, if you remember, when we did the FL Pipeline 1.0 a long time ago, it was called the Speech Lab Toolkit. At that time, we were normalizing all the scans to MNI space. And because we were doing that for the fMRI, so we just did that for all of them. It does have some advantages in that the brains are all nicely aligned to ACPC. I think it's easier to wrap your head around the anatomy that way. But it had an unintended consequence in that if I were to we did that so much, and I looked at so many brains, all of which were in MNI space. If I were to draw an outline of the brain, it would have been off. It would have taken what I think is a more typical shape of the brain and squished it in on both ends and made more of a peak in the dorsal parietal area. So it was a demonstration of just how there is an effect of always doing the normalization. It does change the shape of the scans.
Right. But I mean, conceptually, at least you could apply normalization to the structural and then just do the same transformation, exactly the same to whatever functionals, and to give everything in the same space. And if there was any advantage of FreeSurfer, that because of the using like a population templates or something like that, if there was any advantage in the procedure to use normalized MNI space data rather than raw data, we could potentially do that. But if they recommend not to, then probably we just better leave it as it is.
Right. Ultimately, it would be kind of interesting to see what effect that would have. Right. What effect it would have on the individual, like the morphometry data that you can extract. It'd be interesting to see that. We could play around with that and see what kind of effect that has on in these more troublesome scans. Ultimately, decent scans, FreeSurfer does a pretty good job of the segmentation and surface reconstruction.
And also in that vein, do you know if what is the recommended procedure if you have like lesions in the brain, like patients' data? Do they have a recommended procedure for that?
I do not know what the recommended procedure is for that. I think what they do is, well, actually, I won't speculate. I've talked with a couple of times with Swathi and some other people about trying to look into good ways of labeling brains with lesions. But I don't know how they do that with FreeSurfer. I don't know if they use some sort of template.
I have some masking or something, ability to mask out some regions. I don't know.
Right. And then do like a mirror, maybe like a hemispheric mirror, just so they could do the registration.
Right. I was just curious, not really related to what we are doing here.
Well, we could think about that because so a lot of people do this lesion mapping. A lot of people are doing this. Our lab, we actually have some fairly unique expertise in working with images and anatomy. So that would be a direction that we might want to consider going in.
Okay, we can look in more detail then what is the kind of like the recommended pipeline for this type of lesion data analysis. And I don't know, I will be curious in learning a little bit more about that as well. So
I've just Googled it just because I was curious, and FreeSurfer, they have a page on what to do. So it looks like people are using FreeSurfer even with lesion data.
Well, that would be.
I can send this link just for you for later.
Thank you.
excellent.
It looks like you'd have to go in like brain by brain and adjust.
Right, this might be part of the thing that Jason hasn't explained yet, and about how to edit these things manually when you have any troubles with
Right.
it. Because I have no idea how to, but might get to that
Yeah.
at some point.
We will not get to that today.
Not today,
I think
right.
that it may be that it would be easy enough to identify the lesion, and then if you could do that, then where there's a lesion, just bring it some sort of template to help with the registration, or just say ignore this information, only use what's left to match it to a template, and then instruction.
And also another question for the structural like acquisition parameters. Are there any recommendation as to what's the best quality like T1 weighted image that you can get for a FreeSurfer to run optimally, or they don't care? They just use anything.
No, they do MGH. It's actually fairly old now, and each time we've started a new study, I've asked if there's an update, and there hasn't really been. The only updates have been in the speed of the acquisition, but there's a multi-echo MP Rage acquisition at MGH that's recommended.
Okay.
I looked into it a bit, but like our last round, and it's like 1 millimeter cube voxel size. At that time, they felt like for there wasn't a whole lot of like much advantage in trying to get smaller voxels for what FreeSurfer does. But that again, like the genesis of that scan.
And how long does it take?
6 minutes.
6 minutes. Okay, not too long then.
And there are a few things that we don't do that can improve the two. So we go in, we get a T1. Over the last few versions of FreeSurfer, they've built in the ability to combine T1 images with T2
Oh,
images.
nice.
And that does a better job of doing the skull stripping and can result in better peel surfaces.
I don't know the physics of this, but T1 and T2, they have the same kind of like a spatial deformation type of noise. So this is not like epi versus T1 that they have completely different. So,
right.
So they don't deal with, when they are working with these like multispectral images, they still don't have to deal with like spatial deformations between them. They assume them to be like exactly the same, right?
Right.
Or they don't. I'm asking basically.
I believe that they do not have to deal with that. So I think like in terms of deformation, those are similar.
Right, because if they go to the multispectral, like, I don't know, future, and they enter or deal with the deformation between the functional and structural, that would be a huge advantage for us, at least. I mean, for many analyses that they use FreeSurfer just for structural, I don't know, deformation, like type of analysis, they don't care about the functional at all. But for our analysis, we care about this whole mapping between the two. So, I don't know.
Well, I would say that may be a bias. That may be a speech lab bias there. They have a whole suite of tools for doing functional analysis. I think that knowing the people that are running the lab over there, their background is in structural image processing, so it may be that they're almost certainly they're more interested in structural image processing, but they do care about functional image processing. And in fact, when Bruce Fishel visited us, Bruce Fishel is one of the people that started FreeSurfer and still is the lead of that lab. He many years ago, he's the one that really, when he came and visited, really pushed us to start getting the field maps, the maps and apply them, presumably because he understood how that would affect the co-registration of the FreeSurfer recons. All right.
So I have no more questions. Sorry to derail the conversation.
No,
Please go ahead.
this is great. We use FreeSurfer in this fairly, it's the FreeSurfer's role in the lab expands a bit, but it's and in fact, like the morphometric analyses that we're doing now is something that we hadn't done, and so that's somewhat new. But FreeSurfer, there are a lot of other things we can use it for. And so discussing that, I think, is good. And we have a really good relationship with them right now. Well, presumably we'll continue to have that. And so we have access. Actually, we have, they are very helpful with us. So if there are new things that you think we might want to use, or the other thing, so in terms of what you're talking about, Alfonso, you say like, well, it would be cool if FreeSurfer did this. That would help us. If you could write that up, I can pass that along, or you could pass. One of us can pass it along, because I've found that when I've emailed them, FreeSurfer has capabilities that are not highly publicized. It's like things that people in their group are using, and they'll tweak it to provide a feature, and they just hasn't been written up yet. So it's worth anything you think that would be useful for us to
Sure, I'll send you along like a wish list for Christmas.
Great. Matt, you have a question too? You sure? Okay, so cortical reconstruction, and then of course region of interest generation. So once you have this, we are interested in the cortex and the white matter, but we're really interested in our subcomponents of each. So FreeSurfer, as part of its default processing, after it's actually before this is created, but it'll take the segmented image, and it'll come up with in a volume a labeled cortex, and then all these subcortical structures: thalamus, putamen, pallidum, hippocampus, ventricles, caudate. So we've just moved recently into processing of these in our studies, which we haven't used those a whole lot. So we're using for our analysis. So the term segmentation here means divvying up the image based on image intensity, roughly speaking. And so we say we segment the different areas, different subcortical areas. And that is opposed to parcellation, where parcellation is divvying up some tissue that's of a roughly uniform intensity. So we segment subcortical ROIs, or we segment the cortex from the white matter, but we parcellate the different areas of the cortex. And in order to do that, here's just another way of going through looking at the processing stream here, where so segmentation in this context refers to dividing up dividing up the areas in the image based on their image intensity. So white from gray, this gray blob from the white matter that's around it, this black CSF from the white and gray that's around it. So based on image intensity. For parcellation, what you're doing is you're divvying up some structure that's of a relatively uniform intensity.
And that's mostly like cortical ribbon, or is there something else that you can use for parcellation? Can you do like automatic parcellation of subcortical structures as well, for example?
Yeah. So in terms of the theoretical definition, of it, yes, you could parcellate, say, the caudate into a head and a tail. You could parcellate the thalamus into its subcomponent nuclei. You could parcellate, yeah.
I see what you mean, but FreeSurfer still doesn't have that capability, right? The for parcellation, or they do. Perhaps
I don't know that it. I don't.
It just does it for the whole structures, like it does it for the whole thalamus and the whole caudate, but it doesn't.
The default is to do, yes. So the default is to just segment out these subcortical structures. Correct. Yeah. But it would be possible. So I want to say that someone may have done like some version of parcellating the thalamus a bit. I don't know how useful that is. So, but it certainly is possible for us to go in and parcellate these. Certainly, so I guess like semi-manually. So based on some landmarks, we could draw, and we could say everything anterior to this is anterior putamen, everything that's above this landmark is dorsal putamen. But I don't know that it has commonly used subcortical parcellations just based on T1. If you, so we use the subcortical ROIs, but of course we also use cortical ROIs. We divvy up the cortex based on this labeling scheme that is tailored for speech studies. So we divide lateral, like so the ventral motor and premotor cortex from the dorsal premotor. The areas that are more involved in speech, but the areas that are more involved in moving your fingers and your arm, that sort of thing. And we want to apply that. So
wait, is that parcellation or segmentation?
That's parcellation. So we parcellate the cortex. We subdivide the cortex, which is of a relatively uniform intensity. So I don't know. Ultimately, this stuff is only like understanding the difference between those two terms may only be useful when talking to me. But although no, FreeSurfer does uses it this way. But that's the idea for you to understand. Like you can. Ultimately, it's just subdividing the things, right?
So sorry. So the cortex itself, it's a relatively uniform intensity. So segmentation's not going to do much because it's all the same. So then you go in and you do parcellation based on things that you do.
Right.
Yeah, and I think those terms, it is useful to know which is which because some of the files are named, like on this slide, how that one's named aseg is and then some of them are called aseg plus aparc, right, Jason?
Yes. Yep. And so FreeSurfer uses those terms, and just in general, if someone says, "Oh, I do research on image segmentation," what they mean is, typically, is using the intensity values in the image to divide it. Divide the image into different components. Parcellate is more isn't as universally used. One of the labs that worked closely with FreeSurfer when it was developing its initial parcellation method used the term parcellate to discuss. So they used it the same way. I worked in that lab. So instead of doing it with FreeSurfer, you would manually create all these boundaries over semi-manually, create boundaries around all the subcortical areas, around the white matter, around the exterior. That was segmentation. Then once you did that, you could parcellate the cortex into its different gyri.
And it seems that parcellation does have, at some point, not on an individual level, but from past research, a sort of functional basis, whereas segmentation is a more structural basis. Like white matter, gray matter, parcellation is like, we know this is the motor cortex.
Yes, although that is true. It's essentially you're coming up with these like self-contained. So you got white matter, right? And you've got the whole thalamus, and you've got the whole cortex. But we know that there are even though the whole cortex is uniform in terms of its intensity in a T1, certainly not uniform in its function. And ultimately, something like motor cortex or primary auditory or primary visual cortex does map really well to an identifiable area in the brain. As you get farther away from these primary cortices, that mapping isn't as good. So actually, I don't have this as a highlight here but what I could do is, and I could even, we'll see where we are, but I could go over our parcellation system to discuss what the boundaries are that are in there and why we picked them. We divvied them up in these small bits based on other imaging studies and previous neurophysiological work and our own studies, and tried to identify, well, here are the areas that seem to be active all the time, and here's how I want to divvy them up. And I can there are landmarks that will help me do that. Those landmarks on any given, for any given individual, I think once you get beyond the primary cortices, may not be good indicators. So that's why that was the impetus for trying to come up with our functional ROIs ultimately. But the way that this works, so let's say you've done this now, you have this white matter. So I'm just showing what the purple here is what FreeSurfer segmented as white matter. And then the cyan line here is the white matter surface, and the yellow line is the peel surface. You can then take that surface, here's what it looks like in 3D, fully connected. And when you look at these, the green here are gyri, right? So this is you're not looking at the nice rounded surface like this, the peel surface, which is like this. And here you're looking at this more jaggy looking surface here. So this bit that's sticking up here is this, okay? And let's see, this bit that's sticking up here is this. And so where you have this curvature, this direction, that FreeSurfer by default labels that green, and where you have curvature going in the other direction, it labels that red. So when you see these images where there's nothing overlaid on it, like pretty colors of ROIs, that's what this looks like. So you have the white matter surface here, then you can take that white matter surface and inflate it into a sphere. So basically you think of it as like blowing this up with a bike pump until it's a sphere. And when it gets to the sphere, it's still keeping track of all the information about where the relative position of these in its native space. But it blows up here, and then it takes that and it warps it into matching the FS average template space. So what it's trying to do, it's using the surface curvature. So these individual sulci and gyri. So if you have a sulcus here, like this big one, everybody know what this one is? This is Sylvian fissure, a huge one, and then you have the intrahemispheric fissure here, these big ones. So Sylvian fissure is going to go up. I don't, it's not a big one, but it's here. And then you can tell it's here too. This is it here. And then you have other sulci that are prominent, like this one coming down here, the central sulcus. So you know that this is motor cortex here. This is somatosensory cortex here. And this is a nice, fairly consistent sulcus. So that one would be probably this one here.
Does it use these landmarks to warp it to FS average space?
It uses the curvature information. So it tries to match the sulci and gyri pattern, warp it from the individual space into FS average space.
And if the individual is further from FS average space, or perhaps some areas match up well and some don't, how does it make that decision?
If
there's been a resection or something, and so what it normally uses.
Right. So that if there's been a resection, that I don't know. I'm not sure what it would do. That kind of goes back to the lesion bit before. So if you're just missing information here, this is just no curvature. It's flat. what does it do? Certainly, the more your gyral morphology, where the gyri are, how many there are, whether or not there are minor sulci between two major sulci, that will all impact how well FreeSurfer does in co-registering the brains and in labeling the brains. So it does have an impact. So for instance, on some brains, on the lateral surface of the brain, over here, you typically have central sulcus, precentral sulcus, and a postcentral sulcus. So every once in a while, you have an extra sulcus in here, and that really throws it off. So you have to keep an eye on that. I don't know, like in terms of co-registration, overall co-registration, I still think it'd be pretty good, pretty good, because you have so much other information. So instead of just doing something like an M&I space where you're trying to match extents and do rotations, you have a lot more information because you've got all of these landmarks all around the surface to use. So FreeSurfer, I think, it knows that information. It knows that transition. But what it's trying to do is identify areas where I know that there's a change in the direction here of the curvature, and there's a change here. So it identifies those points. And then it uses population information to try to match the curvature pattern on the individual inflated surface to that of the FS average surface.
Do you know how the FS average, I was just curious as well, template was constructed? I mean, how many subjects, were they kind of the same M&I, or how did that work? 28 subjects, 28 to 32, somewhere in that range. I think, yeah, and, or wait a minute, maybe 40 for this, maybe 40 for the actual FS average. And it was an M&I 305 space. And so, yeah, maybe 40. But yeah, I think I can check on that, but they may have used 40. Remember when we built our classifier from the Buckner 40? Okay. When we built our classifier way back when, so we took a bunch of individual brains and then labeled them and manually corrected them so that they were a gold standard, and then trained it up so that we could apply it to individual brains. And we wanted to come up, I think we were, and maybe for the childhood stuttering. So for Suen's data, those are kids, and some of them were pretty young. So we didn't want to use this template. We wanted to use one that was more representative of that population. And I was communicating with them and asking them what you thought, how many you thought you would need, because it was going to be difficult for us to pull 40. And I ended up doing some testing to see how well you could match it. So I labeled every one of these manually, or one corrected them to get a gold standard, and then tried to match. So I used different templates, different construction of templates. So basically coming up with our own FS average for kids. And you saw that really once you got into the low teens, it started to asymptote. And we ended up using something like around 20 total for that. But and was talking with
the FreeSurfer people, and they said that that's essentially what they saw too. So when you add in those others, it's possible, I suppose, that may capture some more of the variability in anatomy, and that maybe certain brains would help more. But it seemed like it made that big difference. But yeah.
And do they have anything specific to be able to form like group specific templates if needed? If you have like a population that is totally off, but like the normal population that you use to specify the surface average template.
Yeah, there's a set of tools for doing that. But they have a process for generating that. We use that for the CUS study. In that paper that Emily published last year, there's a bit of that described in there. So
when is that recommended to be? What is kind of like the limits of what would be a reasonable range of I don't know, what would you consider normal population to be using the standard FS average, and when do you need to go like off?
I've heard a couple of different things. I've heard there was one paper that said you're fine down to 8 years old. Yeah, and then some others that have argued that maybe that's not right. So when we did this, sure enough, so that was a longitudinal study. So it's a lot of brains, and it takes you can go through when these things are labeled, they're pretty good, but they're not perfect. This one looks really good because it was manually. I believe this one was manually corrected. But if you did want to manually correct them, it'd take you forever to do as many brains as you would want in that study. So what we're trying to do is try to make the automatic labeling as accurate as possible. Sure enough, when we switched to a child template, it didn't make a huge difference, but it made some difference. It made it a bit better.
So Jason, when you did that study, was it okay to create the template based on data that you would then use in the study, or did you base it on other child data?
We used it based on data that we use. So I think I grabbed equal parts. So that was actually 28. That's where the 28 comes from. So I grabbed equal parts children, and I try to get over the range of within each group. So children who stutter, children who not stutter, male, female, and try to in each of those groups go over the range of the ages. And people do that. So there are people that use FreeSurfer and people that use other tools that will come up with a study population template for doing the co-registration.
Right, it's like a Dartel, for example, in SPM, you have the whole Dartel package to do like group-specific normalization, where you create a template based on your specific group, and that is fine as long as you don't biases to one portion of the subgroup that you're trying to analyze or something like that.
Oh, okay, that makes sense.
One of the things I've thought about doing, Alfonso, was if you used a bunch of data from each, like if you had two different groups, like kids who started, kids who do not, and you created a template and just compared and then looked at like what like if I were to deform one template into the other, or for instance, if I put both in FS average space and look at that deformation, that might tell you something that would tell you about like what would be the any consistent, reliable differences between the two groups. Because we wrestle with that. What should you? What is it? If you use a template, we start thinking, well, it would be nice to have a template that was the control the fluent speakers. Then we realize, well, if you do that, if you're warping just to that template, you may be in doing that normalization, removing some morphological effect associated with the stuttering. So that's why we balanced it.
Right, and it would be possible. I don't know if somebody has done this, but if it doesn't take a terrible amount of time, it would be possible to build like use like a general like cross-validation framework on top of this, and get like a group-specific templates and then compare them by using like cross-validation or something like that, and try to figure out what are the differences between those group-specific templates. But the more standard approach would be just to create one single template with all of your data, like trying to make it so that it's relatively balanced to the contribution of the different subgroups, and then use the rest of the tools that you have to look at the individual properties of individual subjects where those differ between the two groups, rather than comparing the actual template themselves, like difference in the templates themselves, like group-specific templates.
Yes, it would be interesting to see what, it does make some difference. I know that from the kids study. For adults, I don't know how, I'd be curious to see how big a difference that makes. If you were, yeah, the way we do this now, the way we do our labeling now, we just use the labels directly from the FreeSurfer labeled surface onto the individual surface. We don't use a classifier. We just, there isn't much difference between the two methods, but in doing so, anytime we came up with our own, like as if you came up with a subject-specific template, you'd have to, with Bobby or somebody would have to go in and manually apply the labels from FS average and manually go in and correct them. Then use that template. I mean, that's not, for one brain cell, but that's kind of, that's why we sort of gravitated toward, or stuck with just FS average, but there's a lot. We'll look into it, but I know there's also, I think that there are other people that have looked into that too.
And in practical terms, I'm also curious, just what do you specify to create this, like to have FreeSurfer and use this particular FS average and template? You have to specify like a file that contains in FS average space which is your desired parcellation, and then another file that tells you in the target space what is the kind of like curvature profile that you would expect on an average subject, or what is the kind of like information that FreeSurfer needs for this, if you want to change the type of space that you want to analyze the data?
Well, so FreeSurfer, so the user of FreeSurfer doesn't even know much about any of that, right?
Right. No, right. I mean, this is all if you ever needed or wanted to do that.
Right. I mean, just in terms of the pipeline, FreeSurfer will automatically do all this for its default parcel labeling systems. So it has this one like gyrus-based labeling system here, and in terms of like what information it needs for that, you need to have a good recon here with the surface curvature,
right.
And you get a map, you warp that into FS average template space, and then you're just basically matching up the labels.
Right, and for the FS average template space, you just have this image of what in the spherical representation, what would be the curvature values that you would expect on average, right, or something like that. What you're plotting in the top right there.
Right.
Right. Okay, makes sense.
And so when you run so all this, I haven't even talked about this, but there's a function called recon all, and I'll get into running recon all. Some probably still today, and so that does all of this. It takes care of all of this, and it's not perfect. Like I said, so every time we run one of these, we do a QA. Bobby goes through, does a QA. I look at them, and if there's something that goes wrong, we decide is it wrong and we can't fix it, or is it wrong and we fix it. But it will then generate those subcortical ROIs by default and a bunch of cortical ROIs by default, but it doesn't do everything for you. So you need to, once recon's run and you're happy that things are working well, then you need to go in and run a few extra commands to label the individual surface with the speech lab labels, and then if you decide that, and so that's labeling surfaces. If you decide that you want to have them in a labeled volume, you run another command, and if you decide that, oh, I want to do some morphometric comparisons, then you run a couple other commands. So one of the other things that we used FreeSurfer for a bunch and is the FreeView GUI for looking at images, and I'll load that up here in a bit. So you can look at all these images here. You can look at, and you can look at other data too. I think I talked about it. So that's what we use FreeSurfer for. But you can do lots of other things. There's functional MRI analysis. There's instead of doing an ROI-based morphometric analysis, you can do vertex-wise morphometric analyses, and there's a built-in tool for that has some pluses and minuses. There's a GWI-based white matter tractography tool, Dracula, which we actually have built into our pipeline. And FreeSurfer works really well with the FSL group, which I thought was a huge plus. So getting more into the details, FSL DTI stuff, I still think it's a big plus. Not quite as big as I thought it was, so 9 months ago. But we'll just focus on the structural MRI, segmentation, parcellation, and ROI. And here's a note to self that about all the ways that we use the FreeSurfer output in the lab. So I think we're familiar. We use it for co-registration images. We're using it for actual morphometric analysis of differences in structure, the volume of an area, the thickness of the cortex in an ROI. We use it for tools from FreeSurfer to do co-registration between our DTI images and our structural images, and we use the ROIs as the basis of all sorts of analyses. Functional MRI analyses that we're working on now on a bunch of projects. Seeding for doing tractography, both structural or functional. So just some nitty gritty about running it. So when we run FreeSurfer, not like SPM, it does not run in MATLAB. It runs directly from the Linux terminal, and you can actually have to change this now. That's right. So there's a module. If you do module load FreeSurfer, it's FreeSurfer version 6.0, the latest version. Many of our data sets that we're using now were originally processed, so the reconstructions were done using version 5.3.
How much of an issue is that? Can you continue to process reconstructions with 5.3 with 6.0? Or do
you should not do that. So actually, the version, there's a paper came out several years ago now, but a paper came out to show that the recons from different versions do differ. Even the platform that you're on makes a difference. If you're doing it from a Mac versus a Linux system, OS and things like that do make some difference. So the general rule is you want to do the reconstructions, actually generating those, doing the segmentation and generating the surfaces, all with the same version of FreeSurfer on the same platform.
Is there anything on the dataset itself that tells you which version was used to process it and the output, or
Yep.
that it's kind of like hidden?
Yes. Nope. You can tell. You can. So, well, one, you can explicitly set the version that you're going to use, and then if you run it, there are files that are generated that tell you what version was used. Okay. So you can. That's fairly easy to find, and when we get to actually look, I'll log on to the SEC where that is. Cool. So reconstructions, you want to use the same version. So if we were to take like a scan from the, I don't know, SEQ PDS, we're not rerunning those. Those are 5.3. If we realize, oh, something went wrong, we would want to use the same version as we used before. If all you want to do is simply visualize the data. Or let's say Bobby suddenly decided that she was going to move to the Caribbean. She wasn't around, and all of a sudden, all of the rest of us have to do a lot more editing of these things. You can do the edits. You can actually edit the volumes in whatever version you want to use. So you're going to do that in Freeview. It doesn't matter what version it is. So when you actually sit down and run this command that'll come up in the next slide, recon-all something, 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 you want to make sure that you use the same version that you're using for the rest of the data in the study.
What does the data extraction refer to here, Jason?
Data extraction.
So same version should be used for
I'm being very conservative. I'm saying if you are going to once you do the reconstructions, you want to apply the labels. Actually, that could be in here too. Labeling and extracting the information from the labeled data, like ROI. Like you can pull out individual ROI masks. You can pull out volume, thickness, that sort of thing. That may be a little bit conservative, but my recommendation would be to just always do that with the same version.
Okay.
Let that version of FreeSurfer, like the same, whatever's under the hood, do that. So when you're working with FreeSurfer, you want to set this environment variable, and this comes up time and again. So the way FreeSurfer works is you'll run a command, recon all, blah, 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 and you just give it a subject name. And but it needs to know in what directory that's in. So even if you're in that directory, it also uses this environment variable to kind of look around for where other information is. And what happens is when you load FreeSurfer here, this module, it by default assigns a subject directory. So I think it does it basically. So whatever. So when you install FreeSurfer, it has its own subjects directory, which has things like FS average in it and other stuff. That's the default. So you want to change it so that it points to your experiment. So an ACE would be the ACE subjects. And what you can do is, so at one time, what I would have said is just in your RC file. So are we all familiar now with our RC files that are in our home directories on SCC? They're a system directory, so they start with a dot, so they're hidden. Dot bash RC. Bash is a certain kind of shell. Think of it as like a programming language that you want to use to interact at the terminal to interact with the system. There are different versions of this. By default, I've been using bash. So in this file, you can do things like set aliases and preferences and things like that. And there are a set of preferences that are handy to set. What I at one time would have said, put this module load FreeSurfer for me, because I use it so much, and then I could set this environment variable later in the bash RC file, so it would load this module. Every time I started a terminal, it would load the FreeSurfer module, and it would set this correctly. But the SEC people have discouraged setting modules. They want you to set modules as you run processes. So,
Also with the bash RC file in general.
oh, really?
Yeah.
Oh, great. Okay, well, so the only actual useful information I have about bash RC versus others is that how you define this variable. So this environment variable here, you should be, if you're not really comfortable with what these are and how they work, you should spend a couple hours getting there, because using our Linux system is going to be so much easier doing that. A lot of processing will be easier doing that. So, but the way you set this depends on which shell you're using. So, like T shell or C shell, it's a little bit different where you have like there's a command that's like set SETENV space, the name of this space, the thing you want to do. So what this means is that if in your environment, so if you're at the terminal and you did something like you type, so if I do CD $, that means address of environment variable. Those are my words, not an actual computer scientist word. But you write this, then it's actually what it's going to do is just replace this with whatever you set this to be. So then you change directory right to that directory. And when you're running FreeSurfer processes, it's looking for that environment variable to be set, and it's going to look for files and direct new files based on where this is. And then one of the other recommendations I have when using FreeSurfer, and we'll see, especially when we're so really across the board. So when we're running Recon All, that's a computationally intensive program. We're not going to log into our VGL server and run it directly from on that server. It would take a lot longer. It wouldn't make use of our nice computing network. So you're going to do things like use QSub, right, and submit it as a job. And you also are and then even if you're using Freeview, we'll see in a bit. You want to write scripts essentially to run the commands. So what you can do is you could always copy every script right to the subject directory all the time, or you could do something like have a scripts directory. So what I've been doing is I have this FreeSurfer scripts directory in project/vu/lab/jt scripts, and then I set an environment variable, in this case SS, and do whatever you want. And that way I can just address scripts that are saved in this one place. So I don't have a bunch of versions of them around. I'm not typically disciplined in this way, so it's been a struggle to finally get here, but it is handy.
Jason, I'm just doing this at the same time. Differences, and I'm not sure if I'm doing redundant things. I thought you were supposed to do export space, and then subject stir equals.
So I think that depending on what shell you're using and what shell you're using,
I think the export is only when you are writing it as part of a file that you are going to be executing. The export is so that it's a global variable and not a variable that is just local to that particular file.
So
And it kind of depends.
the file or something, the export.
Right. If you are using it from the command line, you don't need the export because you are already in the base, like a space, variable space. But if you are within a functional file and you are going to run that you are going to run it something like says bash and then the name of the file, then it's going to have its own bash space to create the variables and everything. And you want to like refer to the base space to variable, and that's what you use export for.
Okay.
Or at least as far as I recall. I might be wrong about this.
Yeah, that makes sense because I think I took it from an old QSub file that I had, so that makes sense. Because in there, I would need to do it, but I don't have it in the bash file. Just turn.
okay, so
Do you want me to plug in and do that?
just to set those, I can do that now.
Sometimes it's should be done.
So let's say I did this. Let's say I did this first. I open a new terminal. Okay. then can do, so let's say I was going to work on the, let's say ACE. So I could do something like subjects dir equal okay, and whenever I do this, you always want to use your tab out. Not only does it save you time, but it confirms that you haven't made a mistake. So I set that. Okay, so now if I do echo subjects dir, so what I'm saying is, tell me the value of this environment variable. It's that. Let's say I forgot the dollar sign. What do you think it would do?
Just say subject dir.
Yeah, it just echoes the thing. So now if I cd to subject dir, I'm in that location with a bunch of FreeSurfer subject directories. And it can do, so if you look at, if I go, let's say I go, so here's my bash RC file. And I do a few things where like some of these are old, they're sort of commented out, but it's like, well, when I run MATLAB, I want to run it this way, which is kind of old, but it's still there. I have some aliases that where I know I always want to go with probably going to use lab, so I just automatically go there. I have an alias for, if I just type VGL, it runs this QVGL command. And then I had a bunch of other things that now we decided are not a great idea. But a few others that I hang on to, like where's my scripts directory and things like that. So if you haven't played with an RC file, the one that is the one that's addressed when you, like, so by default, I think on our system, it's bash terminals. So if you haven't played with that, it's worth doing. And if you have played with it, these things that are in here, it's this doing something on the command line. You can set these on the fly. To make it easier. So if I did this, if I did SS equal,
So Jason, if you have it in your bash or C file, like the subjects dir, and then you write it on the command line, does that override it?
if you write it on the command line, it does. So,
okay.
So what I should do now is just in my bash RC file, add this little bit. I'm going to use it a lot. In practice, I may even have already had it in there. You just don't remember. There's a bunch of stuff that have been.
Yep. Although it's a different subject dir.
There's a different subjects dir, and that gets overwritten. Actually, that's
oh, it's common. Oh, okay.
But that gets overwritten as soon as I run module load. So if I do, let's test this. I'm saying this stuff as though I'm 100% sure, but I'm not always sure. So if I do echo subject dir, it does this. So if I do now module load FreeSurfer, now I do echo subject dir, it moved me to the default installation, like the FreeSurfer installation subject dir. So that's now so one of the things you can do though, you can do this, right? I do bash, and now I do it. No, that doesn't work. I was going to say, if I just do bash, it'll rerun that. But I also believe that it got rid of. Okay, so what I did is by typing bash, I basically reran that bash RC file. And I initially did it without considering that it might then might be that you no longer have FreeSurfer, the FreeSurfer module loaded, but it seems that you do. So that's one way you could do it, or you could just write it over again, type it over. Okay, so now you can. So let's see. If I pick this up here. So if I do. Oh, I thought you said that. And I'm going to try running a command. So this is a quirk that maybe Alfonso can help me with. So sometimes you can address, so if you can address these variables directly to execute, say, a function, and sometimes you can't. So what I had to do here to make this work is I had to add in this. So this is C shell CSH. So instead of bash, it's CSH because this is an old script, and we'll update. We have updated versions of this. So it's basically saying run this shell script, and then I can do something like I don't know if this is going to work, but it's going to as a demo of using the shell script. So Alfonso, do you know what the syntax is for that, like that issue, where I'm just going to kill this.
What did you just run? What was that?
That was BF. That was a script to call preview and load up a set of files and have them look right away. So that's like the next section of this is what to do for that.
Yeah, can we start with them just like loading it from the?
Yep. Oh, from the preview window.
Yeah, like loading an individual file.
Sure.
Subject. Sort of.
I think we can do that. I'll do that because that'll help you understand like what the files are.
Yeah, it's like which file type and which file type.
Oh, sure. Well, we're going to go through all of that. Like ultimately everything we've talked about so far is meant to be prelude to stuff that's going to be useful for you in the near future. We'll see how far we get in that. But I just want to see if I can. I'm going to take a second on this. So, Alfonso, do you know what the difference is there? Where there's a script, it's essentially the same script. And if I directly address it like this, I say, go back a directory, go in here, grab this script, and then run it. I can do it like that. But if I am using an environment variable, I need to, so if I wanted to, if I want to use the one that's here, this version of it, do you know why you need to when calling it to actually run it, I need to put the shell name here. Did we lose you?
Sorry, I was on mute. So I was thinking it might be just because you don't have the run attribute, the execute attribute, as like the third part of the, you do an ls minus al of the name of the file that you're trying to execute. The bfbo, yeah, new. Yeah, so you don't have the X. Oh yeah, you do have the X. So no, that's not it then. This is the one that you cannot run directly, the BF.
What I found, it seems to be something about addressing it through with the environment variable. So if I did this, if I did,
oh, I see what you mean. It's using the environment variable as part of the command line itself, right? That's what you mean.
Right, because ultimately, the way that we've done this in the past is you have the scripts directory right there. But the trouble with that, that's in near your subjects directory for anything. It doesn't have to be just for this. It could be for any other processing. But the problem with that is that you end up with a bunch of versions all over the place. So if you update one and then you move on to another project, it's easy to lose track of that. So if you had things in a central location, and I was just curious about, so if I run this now, so I had to have that there. If I do this, I think it will work. Right. So it's something about actually getting the thing to.
So which one is the command that doesn't work? Is when you are using the $ss as part of the file, the call syntax, or
yeah.
So if you use instead of that, just use the $ss and then bfvo underscore new, whatever. That's the thing that doesn't run.
Yeah. So we can table that for now, and I can in the notes of how to use this, I'll include that.
Yeah, I think the dollar command is automatically translated by the, so I don't know, try with double quotes or something like that, just to make sure that the translation happens. It doesn't try to interpret it as a single.
So try it with double.
No, double quotes, then dollar SS. So put everything in double quotes. Yeah, the normal thing that you would put as the dollar SS, right? Exactly. Yeah, bfvo underscore new, and then whatever.
Right. Well, so the curly brackets sometimes work too for that, but I'll table that for now, Alfonso. Right. It's a tiny detail, and I'll load up Freeview just so we can look at that a bit, and then we'll leave it at that. So I'll load it. I'll do this at Liz's request, but you would never do this. You'll see in practice. Oh, I shouldn't say that.
Yeah, no.
You would. So the way Freeview works, it takes you so long to go through the GUI to load stuff that in practice what you're going to do is just run the command line, and then what you're really going to do is you're going to have a script that says, I'm going to give you a subject number, go through and do this stuff. But this is a good way, and a good way to kind of understand the nuts and bolts of Freeview. So if I load up Freeview, we want to look at volumes and surfaces. And then we may want to apply different things to, like, overlays on top of the surfaces. Okay, so first thing you do, go in and load volume. And I was just in here, so let's say what I want to do, I want to look at the something. Okay, so I want to look at, say, well, I could look at the original T1, right? T1.mgz, and A. I don't need to resample it. I don't need to apply registration file. We're just looking at it in space, and all the other volumes that we're going to look at will be in the same space. So here's the T1. And I can go one step. Let's say, like, well, wait a minute. That's not the original. Let's look at the original. Look at this. So that's the original. So yeah, the T1, to go back to what we talked about earlier, that T1.mgz that's in the FreeSurfer subjects directory is not the original T1. It's been, I think, FreeSurfer may or may not do some resampling, but it does some normalization. And let's say, well, okay, so here are the volumes that we have loaded here. I have T1 and a ridge. Now a ridge is laying atop T1. And I can, if I want to see T1, I can check and uncheck this over here. So there's the T1, there's a ridge, and let's say I said, well, I don't want T1 to be on bottom, I want it to be on top. So it kind of goes in order of processing. So we have ridge, then we have T1, and then let's say I wanted to load another one. So I can just go to this icon here, and I can load the brainmask.mgz file. That's the one that serves as the input to the surface reconstruction process. And if I look at that, you can see if I toggle here, we've had, let me get rid of this. So there's been some, T1 had some normalization, brain mask, and do a bit more normalization, I think. And the skull has been.
So T1 seems to be doing like some type of bias correction, right? So it's kind of like removing
Yep.
or at least something like that, or it's some sort of equalization of the histogram or some sort of like global bias reduction, because there seems to be like a global bias in terms of the intensity values being higher in the most inferior portion of the brain compared to the superior portion, and that seems to be removed in the T1 image compared to the original image. And then brain mask, that's the whole skull stripping thing.
Yes. Yep. And while we're here on that point, in the slides, in our documentation, I have some resources for FreeSurfer, and one of the really great resources is this table that runs through all the processes that are run during the recon all. And that recon all is split up into different stages, and depending on where you are, if you're running something from scratch, you're going to start from just run the whole thing, and it'll tell you what commands are run, and it tells you what the input is and what the outputs are. And so you can see that the progression here. This is very similar. So there is some change in the ordering from I don't know if it's from 5.3 to 6 and maybe 5 to 6, and from 5 to 5.3. There's some change in the ordering, and there's some updates and things like that from them, but this is very similar from one of the next. So this is a great resource for trying to understand what's going on. And in the different flags, there's another link that I have that tells you the different kinds of flags you can add to recon all that do just certain bits of the processing, like, well, everything looks good, or everything ran, but I need to edit the brain mask because some skull was not removed, so I need to erase some voxels. So you don't run it from the start, you run it from the relevant point there. And that link's there. If you just Google FreeSurfer or recon all table, it'll pop up. That's a permanent part of my browser history. Okay. So the reason I mentioned that there is that you can track what processes are done by looking at those steps and then going in and looking at what the individual functions do. Now, when you use the website like that, you click on the functions. Some functions have pretty good some pretty good documentation. Some don't, and then in that case, you go to command line. You can type in process dash dash help, and usually between the two, you can get a handle on what's going on. Okay, so brain mask is there. I can load other volumes, so I'll load up another volume just so I can start to play with some of the other sliders around here. So let's say I wanted to look at the white matter segmentation. So let's say my goal here was to determine, well, does brain mask look like it was done correctly? Was that skull extraction and removal of non-brain done correctly? And was the white matter segmentation done well? So I can load up whitemagg.mgz. And now I can say, well, I want to look at this. I want to overlay it. Well, here, I'll just. So I load that up. Every voxel in here that's non-zero is going to be considered. Not necessarily white matter, but not cortex. And I could have done this when I loaded this, but I can change this to heat. And when you change it to a color map like this, you can set voxels, so voxels that were 0 are just not going to show up, so you can see what's behind it. So you can see an overlay, and you can do things like change the opacity, so you can get a better sense of what the actual intensity is for what's underneath here. Okay? Then, let's say I thought, well, okay, the segmentation looks okay, the original gray-white segmentation. Now I want to look at the surfaces that were generated. So let's say I want to look at the gray-white surface. So I go to LH.white, and actually let's do a test here. I don't know if you can do 2 of these at once. Try. 2 showed up there. All right, so that's interesting note that you can load up multiple, use typical Windows control. So you can load up multiple of these. And let's say, well, I also want to look at the field surface. So, I'll look at these things.
You were looking at data and you wanted to look back and you realized that there was a flag that you needed to put in to do another set of analysis. If you added that back in, it wouldn't go to the whole recon.
It depends on what
It depends on how you do it.
So it depends on, recon will work from whatever state you want. So what you would do, you would say, okay, where is this flag going to be? And you find, and then you say, okay, well, I want to start. It literally runs separate. I don't know if you can do everyone individually using the recon all. So recon all is basically a giant wrapper around all these commands that were back. If I go back to here. So recon all is essentially a big wrapper that does all these steps. And I think you can break these steps down into, so one of the things you can do is you can do recon all, auto recon 1, and that runs this first step. So it's basically doing normalizing the images and doing skull stroke. And then in recon all, and it's doing some segmentation. Then recon all step 2 is doing some other things like where it's basically preparing it to generate the surfaces. And then recon all 3 is so recon all 2 gets you through this is roughly gets you through generating the individual surfaces for the subject. Recon all, auto recon 3, that step. So if you did recon all space dash auto recon 3, that does these final steps where you're going to warp it to the FS average template, or if you could put in your own template if you wanted, and it'll generate some stats for you. It'll do brain label, so give us some cortical labeling and generate some stats for you. This is sort of like the frosting on the cake of all this other stuff that comes before. So what would typically happen is you run recon all to the end, you check it, you determine one, there wasn't some catastrophic failure where the brain just looks like mush. And then you look through and you determine, oh, it looks pretty good, but actually there was a mistake. There's an error in this spot, so I'm going to fix it. Now, you don't, that, for our high quality adult T1 data, we don't have to do a whole lot of correcting. We do some correcting on just a few of the ACE scans, and we do a ton of correcting on the Kitsu starter.
I guess like my question is I'm trying to get a handle on as we're starting to figure it out. If we do something wrong, we rewrite everything that's already done, or is there some sort of saved thing like that sort of appends it? Like what is that sort of like?
You can do both, okay. Right? You can do both. So like ultimately you may not ever have to run recon. You can, but you know, I guess we got new studies starting. So yeah, any new data coming in, you could run recon. So, especially in your case, Liz, I think, you know, you might be running this. So, but I think it's good for everyone to kind of know how this works. If you run it, we have scripts for doing various steps of the process, and we do things. We have so if you're running it and you're doing an editing, if you're doing a review with edits, we have this process that Bobby and I developed to try to cut down on the chances that you're going to really mess something up. But at the end of the day, that it's still possible that one could overwrite some data that's difficult to recover. But just talking about, I guess what we would call it, but like in practice, you do need to rerun certain steps here, and it will, and you determine what that step is, and then it will overwrite files that it needs to. And you have a log. So if I were to run recon, and I go, if I run recon, this is the FreeSurfer directory, So this is subject. This is in the rhythm study. So this structural data recon is the subject dir. And if I look in the see all these subjects listed. And in general, what I would suggest that people do is try to not have any additional, limit the number of additional files in this directory. So if you're doing something like generating stats tables, don't have it pop up in this directory, create another. So if you're doing individual stats, those just go in the subject's individual directory. But if you're doing group stats, create a directory, either in here or somewhere else. It's group stats, something like that. So that this is mainly just a list of the subjects, and then there are a few other files that are handy to have in here that FreeSurfer is going to look for in its subjects directory. Those files could be literally in here, or they could be links, but that's not something I have to worry about. But if I, in this subjects directory, there's a directory called scripts, and in that you have things like, okay, let's say, and that tells us which FreeSurfer, which version of FreeSurfer was used for the most recent recon processing call for this subject. And then say, well, but what was done? So you could, there are all these scripts in here. Log, and this keeps track of all recon all calls. It'll list the actual command that was run, and it lists the date, and then it includes all the output, and that just isn't just the most recent. That's all of them. So if I were to keep going down, you might see that it was run again from a different processing step. And there are some other lines in here that give you some other information. So just in terms of this, instead of giving the output, just gives you a quick name for the process of it. And if you see these processes that were run, so here, let's see, this was way back in 2017. Actually, that's not so bad. Not too old. And if I keep going down, no, okay, so bad pick here in that we did not have to rerun recon, but if we did, you'd see it say another recon all for something like this. And then when you look in these, one of the things if we do a detailed description of the review process is you get information like finished without error, which is like the first step. You run recon, you want to check these files to make sure that everything ran without an error. It'll tell you if there was an error. So the good thing about FreeSurfer is that it does do a really good job of telling you what was done. So if something went wrong, you can go in and see what it was and recreate your steps. The only thing that if you were to overwrite manual edits, that's the one thing. So when we do the review process, we have all these steps that seem somewhat asinine at first, but they're all meant so that you can't overwrite the manually edited volumes. Okay, so I go back to here. So I've loaded up a bunch of surfaces now. So notice there's a volumes list and a surfaces list. And just one thing about how this works, if I go back to, so if I want to get rid of the white matter volume, right, I can do this. I can turn that off. But you also see that there's a list of information, so you can do some settings here. So if I look at that and I click on it, the check means it's going to be viewable in the window in whatever position it's in. By this, this highlighted bar means that it's the image of the file that is actually being addressed by these controls here, which is a huge pain in the butt. But so if I say I go here and I'm looking at the white matter over here, and it's the thing that's on top, and I'm playing around, and I do this, it's not going to do anything to the white matter. It's going to do it to whatever one of those highlights. That might seem like you'll notice that becomes kind of a pain, but it's just something to keep in mind. If you, so let's say I am here, I already use opacity, set these color maps here. Let me get rid of this. And I'm going to highlight grain mask here. And let's say I thought I wanted to change the appearance of this, so the brightness and contrast. You can do that by changing these sliders. And I don't, window versus level here, I'm not really, someone should look up what that does. And Windows, I don't know what it's doing exactly, but it changes the brightness and contrast. Min-max, do what you think it's going to do. But what happens here, these are all sort of dependent on each other. So we saw an instance yesterday. So for whatever reason, occasionally when you load these up, I think it's following a crash, or say, let's say, yeah, for whatever reason, this just crashed without you closing it. In that case, it seems like what happens is there's some temp file that gives you, that lists your preferences for this, and one of these will load up like this, so everything is 0. Right, so imagine that this was loaded so that the brain mask was all zeros. And depending on what kind of file you have, it might show up. I'm not finding it, but sometimes it'll show up everything's 0 and it looks like there's no data there. Then you just want to, you always, if something seems surprising, look here and make sure that these look like they have reasonable numbers for what you want to view. Then you can do things like, so for the white matter here, you can do, you can click on the white matter. It doesn't matter, like I clicked, see what I did, I checked it, but that doesn't change which one's highlighted. So I can do things like invert the color scale. There are a few different color maps you can make here. So I don't know how often you'll make use of that, but you may.
One question: how does it know to show you the PL on the white surfaces on the structural data, but not the inflated one? Is that based on the name
So
of
it
the
actually
file? Or?
it is showing you. You mean over here?
No, I imagine at the bottom right it shows you the 3 of them, right? But in the one that you have in the center, the big one, the one, it's only showing you those 2. So I mean that's logical because it's inflated on top of the
Right.
others. That makes sense. But how does it know to do that? Does it have an option?
I think
Or is it based on the name of the
I
file,
think
or
it's built in that way.
it's kind of like in the name of the file that when you load inflated, it won't try to show it on top of the
Because
structure.
it's kind of meaningless. So what it's doing here is it's only showing you. So the white matter and peeled surfaces here. You know, that's a collection of vertices, and they have a position in the volume. So this is actually where that surface would be with respect to the volume. Where the inflated surface, its representation in 3D now is really doesn't have anything to do with the location of that vertex in space. So you know, it conveniently so.
I was just going to say, I'm guessing also because this is their naming convention.
Right. So if you're entering like different naming files, it wouldn't work in the same way, probably.
Exactly.
Right?
If they were importing somebody else's naming convention and you changed it, I could see there could be more slip-ups. But considering it's their program and their naming convention, they probably just, if it says inflated, you only show it.
Right, and
right?
yes, yes, and so they do it by default. And what up until maybe this version of FreeView or the one before, what it was bad about doing was, so if I go, let's say I'm going to uncheck these. So just so to go back to just tutorialness, you can change what this window of images looks like here, and you can change which image shows up in this main window. And so you have sagittal, axial, or coronal, axial, and you can click here. It will update where you are in these other 3D volumes, but it will also update where you are in this other image, which is the surface. And you can, so by default, it opens up where you see these slices going through, which indicate where these volume slices are. You can, I find that when I use this, that those typically just get in the way. So I will often do this. So this is the peel surface, and you, let's say you're, well, like it's tilted and it's a pin above, and I figure out how to rotate this thing. Do that, and rotate back to its native position. And under the peel surface here is the white matter surface.
Right. It also seems to be showing the curvature, which you don't explicitly tell it to. So I imagine that it's also using kind of like the naming convention to do that, right? to get like the green and red values, because that's typically like in a file that's called lh.curve or something like that, right?
Yes.
Yeah.
Yes. And what's interesting here, yeah. So yeah, I think that's also relatively new. Like doing that when you load it, that actually saves on some of my assurances that you'll want to switch over to command from the command line. Is this actually by default it's pulling it up? That saves one additional step you have to take.
It's just hard to judge.
Sure. So if I click on here on this surface, note that it will also see if I can. I can click on this surface, and it will actually go to. It will update this. So this is, and if I show the peels, it's going to do the same thing. And it always ends up on the surface. It doesn't end up over here. If I click here, if I were to put those slices back on, you'd see, we already showed that, but you'd see that the cursor, in terms of where the center is of those slices, jumps around too. But if you're looking at the inflated surface, that really doesn't make a whole, let me step back. So the inflated surface, the connection between that and here is still kept in mind. So even though it's not showing up, and this is relatively new, only the last version or the one before, where you can click on this and it'll actually update a location. So if you see something and say, well, let's this, you can actually see where it is. And okay, so if you were to look at a scan, say from the CWS study, Children Who Stutter, and you looked at the original inflated surface, it would not look this nice. It would be jaggy and the little dots, look like little points, due to poor surface reconstruction. But these look pretty good right out of the gate. So the other thing that I want to draw your attention to, which is very important, and a very useful part of the GUI here, is this down here. So this is giving you information about where you are in the image, whatever file you happen to be, well, all the files, whenever you're clicking around, and the value. So if I were to click here, it's going to tell me, so you notice that there's white matter, gray mass, T1, ridge, all these. There will be a repeat of that here, right? All the files are there.
This is really great. I feel like I'm starting to reach that saturation here. I don't know if anyone else.
Yeah,
feels
hence
the
the
same.
scooching towards the warmth of the
I know.
Yeah.
I'm happy to stop.
Yeah, because this is great, but I want to make sure that I'm
I
not.
think the 2 hours is also the point where the recording, it becomes too hard to find stuff when the video is longer than 2 hours.
Like,
Even
pick
if the
up-
content is all gold, like this.
Sometimes it's all just like brilliant, revelatory.
All right. Well, fair enough.
Yeah.
I was waiting for somebody to say that.
Yeah. Yeah,
So
this has been great though. We could pick up with this sort of interaction.
okay, maybe as an assignment for the next one of these. And so, by the way, I am out of town the next 2 Mondays. I'm here through Friday, so if you guys wanted to pick this up later in the week, we could do another one, or we could do it when I get back.
I'd be open to it later.
I'm not going with Jason, but I'm also going to be out of town for the next 2 Mondays. So that's perfect timing.
Yes,
Okay.
I agree with that.
Okay.